Hi, in this video we're going to talk about the singularly linked list. In this linked list we have first created a node as the structure. We have input info and a link, a node as a data, and a link that is going to be the connected to the next node. Over here we have the starter to the node as the add defined. So in this program what we're going to see in the singularly linked list, over here we have a particular structure of operations where we can to add to the empty spot or to particular positions to the beginning and or to the middle, where we get to display the old set of elements and to delete particular ones. Let's see how it works now. So at the first we got the different functions out here. The first function is add at empty, an empty spot where we get to add to a random position where we have nothing there. So there's a temporary that's created. The temporary is equal to the new node. The new node is equal to the info, that is going to be the data, and the other one is of the link, that is going to be null, that's going to point to the next node. Add is going to be temp. So at random, when we put it into a random empty spot, that's going to be the add, that's going to be the beginning, then it's going to be the null. So we have add at end. Here we have a node pointer of temp and a pointer of p, where we're going to explain as the p is equal to add, where the tempo info is equal to be data. If that p is going to be the null, then the temporary link is going to be null. Then when we're going to add an element to a node, that's going to be the end. The previous one's address gets copied to the present temporary one which we're going to add, and that null is going to be copied to the present one. So that's going to be addition to the end. To the beginning is the node that's going to be the temp. You gotta add the new node at the beginning, where the previous one is going to stick to the second position, where is null, that is the address value of the node, is going to be copied to the first one, that is the temp, that is going to be the add for what we have done in a particular position. Take it in case it's going to be in the middle position. It's going to be middle. The previous node's address and the following node's data is going to be copied to the present node, that is the temp. That's going to work out. So then we're going to copy if the link is not equal to null. This is going to increment its position one by one, so x is equal to x plus 1. So finally we get to display the whole set of now what is there. If there is nothing to display, then we get display raw linked list is empty. Deletion is the same already. So we have the same temp and p as the pointer variables, where we check if there are any elements in the linked list. If there is none, it shows up a preview of linked list is empty. If it is so, it goes and asks you furthermore like what is going to be deleted, the particular node and the position, where it's either from starting from the add or to the null, that's going to be the tail position. So this linked list is going to work that way. Let's work it out and see what's going to run in the program. So we get to add to an empty first. Let's see, get 24. So let's add at the end now. So if we add at the end, we're going to add 53. So if we display, it's going to show you 24 and 53. Now let's add at a particular position, that's going to be the middle of 24 and 53. Second position, 66. When we display it now, it's going to be 24, 66 and 53. Let's delete a point. Let's delete 24. So 24 has been deleted, and we display it, we have the rest, 66 and 53. Now if we add to an empty spot, when we display it, is going to be there. So when we have ended it, we get to display the whole set of elements and get to delete particular elements in the particular position. This is how a linked list is completely done. Thank you.